All right, so today we're going to start looking at trigonometry. So the first half of the year was basically algebra. Second half of the year is trig. Doesn't mean that we don't use any algebra. We still do some kind of basic algebra, but it won't be, Wyatt, just turn around, thank you. It won't be as in-depth as some of the algebra that we have. So let's just start by looking at the word trigonometry first. Break it down, see if we can find something in there that we might know the meaning of.
Triangle. Try.
Okay, yeah. So let's start with try.
There's not geometry.
What's
Geometry.
what's try mean?
Geo.
Three.
Pass.
Okay. Anything else being part of that word that you recognize in another word?
Geometry.
Oh, but he
What?
did geometry.
What part of that word?
Geometry.
That's not how you spell
Not quite
it.
sure.
But it like means
So there's no geometry in that word, but there's part of the word. Yeah.
geo.
The suffix metry, which means
Met-
like related to mathematics.
All right. So we have metry.
Gono, like-
What does metry mean again?
I don't know exactly what it means, but doesn't it mean like to relate to math, like mathematics?
It means something a little bit more specific.
Shapes.
Like
Geometry.
geo is earth.
Geothermic.
Metry is measurement. So one of the original things for geometry was learning how to measure Earth, because obviously at that point they couldn't leave Earth, but they could measure things about it using math.
Yeah, we still can't leave Earth.
Is it like
Measure.
the measure of numbers? Well, there's a no.
Okay. And is there
Number units of measure?
anything else up there
Triangle
that
measurements.
you recognize maybe as being part of something else? Like you've seen this maybe part of it in other things.
Geo.
Try.
Yeah, we've got try.
No, the other try.
The other try.
Oh,
So
yeah.
that's
Trying really hard.
That's part of
the
metry.
me try.
Yeah.
Tray.
So something we haven't underlined.
So,
Mono.
Gono.
Don't.
Oh no. Oh no.
Gono as in Rio.
How about, let's go with just gone. I'm not sure, the O is just kind of extra because it likes to be there.
God.
Like there's nothing?
But where do you see G-O-N?
Oh my god, at the end of
Pentagon.
At the
polygon.
end of
Yeah.
shapes.
At the end of a shape. At the end of a shape.
So it's the measurement of three-sided shapes?
Yeah, so gone is,
So triangles.
so gone has to do with sided. Pentagon, hexagon.
Three-sided shapes, which are
octagon.
triangles. So the measurement of
I
triangles.
was just about to say
The
that.
pentagon's
Yeah.
going down.
Three-sided measurement.
So in trig, a lot of what we do is somehow looking at a triangle and measuring something about it, whether
Isn't
it's.
it only triangles?
We study other things, but that's a lot of
What
what
are
we
the
study.
three-sided gongs
The
in there?
gong.
Oh, that's for triangles, but there's other things we do besides just triangles
What
in
else do we
trig.
do?
Pentagon.
We do a little bit with circles,
I mean, circles are terrible.
Average.
and then we do some things that are less visual eventually. But we're going to start out with something today that's about a triangle.
I'm a visual learner.
So here's an example of something that you could have in trig, and it involves making a triangle.
I have a question.
Yes.
Is our final going to be everything over the year or just trig?
The final will cover mainly just trig.
Okay. Because I know some classes do everything and then some classes just do the second half.
Yeah, the second half. All right, so let's say that you had a building over here.
Yeah, I don't like that your feet are
Okay, guys, I need you to be quiet. Wyatt, do I have to move you up here?
No, sorry.
So let's say we have a building, and you're standing somewhere away from the building, and you know the distance you are from the building. Let's say that you're 200 feet away.
Oh, we finding like the slope of it?
And if you wanted to figure out the height of the building, you just need one more piece of information.
Height.
Well, let's say you can't figure out the height directly,
Oh.
just by looking at the building. But you could figure out, that out,
Yep.
the angle
And then you find,
to the top of the building. And you're like, well, how could you get the angle? Well, if you have what's called a transit, it's a tool that you can use to survey property. You can measure property lines, you can measure angles with it. And all you have to do is, it's on a tripod, you take your transit,
the thing they look through?
yep, you look through it, and you point it at what you're looking at, and it could tell you the angle. When you start to tilt it, it knows the angle it's being tilted at. and let's say it told you that this angle is 40 degrees.
And that one's 90.
Yep, and this one is 90.
And then you add them up, and then you find out, you subtract from 120, and then you can find out that the measurements.
Yeah, you can get all the angles in that triangle. And if you draw this triangle out, you can find the height of it. And finding the height of that red triangle represents the height of the building. So that's an example where you're measuring a side of a triangle to figure out a problem. Okay? Another example would be like, let's say you had a fire. Okay, so there's a fire somewhere in the forest. If two people can see the same fire, or they can see the smoke, then they can use what's called triangulation to figure out exactly where it is. If only one person can see it, you can't do it. If you're the only person that could see the smoke, you could say, from my position, the smoke is in that direction. But you couldn't say if it's half a mile, 2 miles. You couldn't tell how far away the smoke is. But if you've got two people, so somebody here, and somebody here, all you have to know is how far apart the two people are. And that's easy, because if you reach out your phone, you can just get your coordinate, and you can figure out how far apart two things are as long as you know the location of them. Okay, so you can figure out how far apart they are. So that distance is easy. Then the first person can say, from where I'm standing, I see the smoke somewhere in that direction. How would they know what that direction is? Compass.
East.
Okay, whether they have an app or just a real compass, it will tell you, if you turn it, which way you're looking. Same thing with this person. They can say, from my direction, I can see the smoke that way. And both of these numbers would be known. Say that's a 45, and that's like a
How would
40.
those be known?
With a compass.
Okay.
Once you know how far apart the two of you are, and you know the direction each of you are looking, you can figure out exactly the object that you're looking at, where it is. And that's called triangulation.
I love triangles.
Right? This problem might be a little bit harder because it might not have a 90-degree angle in it like the building. But you can still figure it out as long as you have 3 pieces of information. In this case, you got an angle, and you know how far apart the two of you are based on your coordinates, GPS coordinates. Right? So that's another example where you could use trig. All right, so what we're going to look at for the first thing is it will be an application of a right triangle, and it's going to involve finding distance. Okay, how do you find the distance between 2 points, and how do you find the midpoint between 2 points? So now when you go to Schoology, the first thing it says is pre-cal, first part of course. You're going to click where it says trigonometry, second part of course. So all the homework is still in the same folder, but it's now in the trig part of the folder, not the pre-cal part. All right, so let's say that you have 2 coordinates, and we're talking about 2D, okay, not 3D coordinates. And you want to find the distance between those 2 points. We're going to draw a shape to help us find that distance. Anybody have a guess what shape we're going to draw?
Triangle.
Yep, we're going to make a triangle.
That works.
Okay, so here's our 2 points, A and B. If A and B lined up horizontally or vertically, it would be easier to measure the distance, especially if you had a grid. Right? All you'd have to do is count. Like if I put a grid in there, and the 2 points lined up horizontally, you could just count how many over. But when they're on a diagonal, you can't count. Okay, so we need another way to figure it out. So that is what I want to figure out. The distance between A and B. So the way we're going to figure it out is we're going to measure something that's easier to measure and use that to figure out that distance. What shape did I just say we were going to make?
Triangle.
Yeah, we're going to make a triangle.
So smart.
Okay, so what I'm going to do is let's just make these different colors so they stand out.
Mr. Hager,
Yeah.
why can't we use the distance formula?
Well, if you know the distance formula, then yes, that's what we're going to be using in the future. In case you don't remember the distance formula,
I know.
we're going to figure out what it is.
X squared, x1 minus x.
Okay, so what I'm going to do is to make a triangle, I'm going to drop in a vertical line from that point, and I'm going to put in another line
At the bottom.
at the bottom. So now I'm looking at this triangle that has the two red sides.
Oh, so you can find the bottom and the side, and then you just have to find one, right?
Yeah.
Is that like a squared plus b squared equals c squared?
Yes. Okay.
Look at me.
So let's
Job, sweetie.
start. Okay, Wyatt, can you come sit up here for me? Yes. Thank you. So let's start with the bottom side. I want to find the length of the bottom side. Now, to find that, think about if you were finding the length of something on a number line. Like if you were here and then you were here, and you want to find out how far apart those two values are. What would you do with those two values? You would subtract. Okay. So to find the length of the bottom, it's going to be from here to there. We are going to subtract two things.
Wait, what are we subtracting? They just count?
So, well, we don't have a grid and we don't have any numbers.
Oh.
So we've got to figure out what two things can we put right there. Look at this bottom side. What x value does it start at?
You can't tell. There's no lines.
Well, it's going to be
X1.
something with a letter. Yeah, it starts at x1,
Next, y2.
right there. And where does it stop?
X2.
It stops at
x2.
x2. So if you take x2 and you subtract x1, that will give you the length of the bottom side from there to there. x2 minus x1. Now let's do the same thing for this height. For this side, what is the y value that it starts at?
Why?
Y, that's y1. I know it's y1 because it lines up with that point. And that point is y1. So it starts at y1. Where does it stop? Stops at y2. How would you find out how far apart y2 and y1 are? You subtract them. y2 minus y1. And that's from there
So y1's on the bottom?
down to there. Yep, this is y1 because it lines up with that, and I know that's y1. Any 2 points that line up horizontally have the same y value. All right, so now I've got the length of the bottom. I've got the height. I'm going to use those two things to find that. What do we call this side?
The hypotenuse.
Yeah, we're basically solving for the hypotenuse. What's the theorem that we can
A
use
squared
from
b
geometry?
squared equals c squared.
And what does that mean? Because I don't have any B's or C's up here.
That
Well,
means
lowercase b and c.
The side and plus the bottom squared equals the hypotenuse squared.
Yeah.
legs.
So this is a leg. So we're going to plug that in right there. This is another leg. So we're going to plug that in right there. And then C is the length of the side that I'm trying to find. That's
Hey, read that song? Hey, read that song?
what?
Legs.
Legs
ZZ
by
Top.
ZZ Top. Yeah.
Sweet.
Uh, So let's fill everything in. They usually do it in alphabetical order. They put the X's first, then they put the Y's.
Do we square both of them?
The way I drew it, I put the Y's first and then the X's. It doesn't really matter. You just have to square each of them. So I'm going to do it in alphabetical order. Let's put the X's first. And yep, you need to square that. Then let's put the Y's second. Again, if you put the y's first, it doesn't really matter. And that's equal to c squared. But what we want is c. C is the length.
Sure.
So then you just square root.
Yep. So now if you take the square root of each side, you have this. And you cannot cancel that square out. If that's all you had, you could. But once you put a plus sign in there, now you can't. Okay. So we have to just leave it like
Can we
that.
just square root when we're done?
Yeah, we can do it at the very end. So that's what would be on the left side, and what would be on the right?
C.
C. So that is the distance formula. I think I wrote that down right there. Is that what we just had? No, square root of.
Oh, that makes more sense now.
Okay, so that's the length of the bottom squared. That's the height squared. And when you add them up and take the square root, that's the Pythagorean theorem to find the hypotenuse.
I thought Mr. Sandin was just throwing letters in my face.
Me too.
No, so the distance formula is really just the Pythagorean theorem. That's all it is.
Cool, yeah.
Which is a lot of work.
Well, now that you have the formula, we don't have to figure it out again. We just have to take the numbers and plug them in. Okay? So this is what you want to remember now, so we don't have to go back and figure that out again. All right. So now to fill in these numbers, let's label each one of them and where they would go up top. What would the 4 be?
Y, or sorry,
X1.
Yep, it could have been x1 or x2, but it has to be an x. Now that we decided it to be x1, all the other ones are kind of automatic. What does the 5 have to be?
Y1.
Has to be the y1 and the 3,
X2.
x2, and the 2, y2. Okay, so when I do the distance formula, the first thing I do is this. I put down all the symbols and numbers, because there's a lot of them, so I don't forget it. All right, now let's fill it in. What number goes in the first spot? 3. And the second spot?
4.
Okay, and we'll call the third spot over here.
2.
And the fourth spot?
5.
5. Okay, so now we'll see what we get.
What's up?
3 minus 4 gives us,
-1.
and when you square it,
1.
-1 times -1 is 1. How about 2 minus 5?
-3.
And when you square that,
9.
9.
Gives
So
you 10.
as an exact answer, the distance is the square root of 10. If they want it as a decimal, well, you just plug it in. I would say if they don't ask for the decimal, just leave it as the square root of 10. If they did, I would put 3.16. Any question on that one? Okay, so one of the reasons that we look at doing the distance formula is because sometimes the number underneath the square root simplifies. 10 does not. Okay, that would be a final answer. In this one, the number that we get under the square root, it is going to simplify. So if you don't know how to simplify square roots, I'm going to show you, because it's something that we do all year in trig.
Oh.
Okay?
Well, you screwed.
Well, I'm doing stats next year.
Same.
All right, so I'm going to set up my distance formula.
Oh,
Put in your difference, square it. Put in your other difference, square it. And let's start filling it all in. What could I fill in for my first number?
4 minus
Okay, so I can put a 2.
2. And then 10 minus 6.
So 2 minus, what did you say goes here?
4.
Yep. So we did the x. So we did 2 minus 4, and then we're going to do
6 minus 10.
6 minus 10. That's fine. Okay. What's 2 minus 4?
-2.
-2.
And when you square it?
4.
And 6 minus 10?
-4.
And when you square that?
16.
16. So that's going to give me the square root of
20.
20. Okay. Now, 20 is one that we can simplify. Okay? There's different ways that you can simplify square roots. If you have a way you use and it works, I would just stick with that. If you don't, here's one way you can do it. Out of all the numbers in this list, you need to find one of them that we divide into, and I'm just going to stop with that. Find one number in that list that divides into 20.
4.
4. Okay, so what we're trying to do is break up the number 20. 4 times what?
5.
4 times 5.
And then 2 times
Once you break up the square root of 20 into 4 times 5, you can split this into 2 square roots, just like that. That's a rule with square roots. If you have multiplication, you can break it into 2. Now, when you do that, if you pick the number from this list, one of these should simplify nicely. The square root of 4 is how much? 2. Square root of 5, you can't break anything up.
So do you have to do that?
Yes. Yep. And you can double check that you're correct very easily. Type in the square root of 20. Okay, you get 4.47. Type in 2 square root of 5. You get the same thing. All right, so the only time that you can write it as a decimal is if they tell you round to 2 decimal places. If they say leave your answer exact, I'm looking for that. Yes? Yeah, just saying.
If we went to the scale square root of 20, would we get like partial credit?
Yes.
Okay.
Yeah, because you did most of the problem, you just didn't simplify at the end. Kind of like if you left an answer like this, 3/6, and you didn't write it as 1/2. You'd probably lose a point for not simplifying it. That'd be something I would just grade manually. All right, so here are those steps again, if you need them. So summarizing what we did. We got square root of 20. And the way we simplified it is we factored the number under the radical sign. That's called the radicand. So we factored the number 20. If you can factor it so that one of the numbers is in that list that I just gave you, that list is called perfect squares, then you'll be able to simplify it. If you had a number like square root of 11, you can't break that up. A number like square root of 7, can't break that up. Square root of 6, no. Square root of 12, yes, because 4 goes into 12. So you factor it, and then once you factor it, you break it into 2 problems and you simplify what you can.
So on the last page, you listed off a bunch of numbers that multiply into things that you could choose from. Is that just because those are perfect squares? Or?
Right. These are all the numbers you can take square roots of.
Can you go
Okay.
back?
Yep. So you might think, well, yeah, I could break up 20 into 10 times 2. Well, with my method, it's just not going to work. If you have a different method that does work for, that's fine. But you've got to pick a number that's a perfect square. And sometimes there's more than one. If you pick a number that's not the biggest one in that list, it's okay. If there's more than one that works, you're just going to have to do it a second time.
What are all the perfect squares? Like, can you run a list so I can write them down?
Well, I listed them out a little bit.
Anything that can be multiplied
Yeah, I
by
don't.
the same thing twice.
So I did,
Those are all perfect squares?
yeah, I don't know how much higher, we're going to go. So 81, 100, 121, 169 would be the next one. I would say in general, you're probably not going to have to go much farther than 12 times 12. We already did this one. All right, let's try this one. Square root of 48. Anybody see 2 numbers you can multiply to get 48, and one of them needs to be in that list?
4, 12.
Okay, so we can break that up into 4 and 12. I will tell you 4 is not the biggest one. Because of that, we're going to have to break it up again.
16.
So we'll just do it this way and then see what happens. Okay, so everyone agrees 4 times 12 is 48?
Mm-hmm.
Okay. What does the square root of 4 simplify to?
2.
Okay, so we have 2 root 12. And if it said to reduce it as much as you can, and you put that on the test, and I took a point off, you might be like, well, wait, I reduced it. Not as much as it can be, though. Okay, we can go one step further.
1 6.
How can you break up 12?
Divide by 2. Can you divide them both by 2 and 30?
So we want to break up 12, and I want you to pick a number that's in this list. 4 and 3.
Wait, I don't understand.
4 times 3 is 12.
So when you break up the number, it has to be a number from this list. So if you were thinking 6 and 2, well, yeah, 6 times 2 is 12, but 6 and 2 aren't in that list. Okay, but 4 and 3 are. So this 2 stays right where it is, and I broke up 12, 4 times 3. Now, what's the square root of 4?
2.
So we have a 2, another 2, and a square root of 3. What's 2 times 2?
4.
Okay. So that is as simplified as the square root of 48 gets. Now, let's do it a different way. Does anybody see, besides 4 times 12, a bigger number in that list? Yeah, 16 times what? 16 times 3 is 48. And what's the square root of 16?
4.
4. So if you find the biggest number, you can generally be done in one step. Sometimes the biggest number isn't as obvious. So if you find a smaller number, that's okay too. You just have a few more steps.
Is it okay if I use like a different thing that my freshman teacher taught me?
Yeah. If you're getting 4 square roots of 3 when you do it, then that's fine. If you're getting something else, then I would say no. All right, any question on that one? Let's try one more. How about square root of 60? How can we break up the number 60? And if you can't find a big one, then just start with a small one, and that might be all that there is. Yeah?
Is it 4 square root of 15?
So we can do square root of 4 times square root of 15. So we break it up into 4 times 15. And what simplifies there?
2.
Square root of 4 is 2. So the square root of 60 is 2 square root of 15. Now, if you look at 15, you might think, well, wait, 5 times 3 is 15. Well, are 5 and 3 in that list?
No.
No.
So that's it?
So that doesn't help. Yep. Again, you want to check your answer? Very simple. Type in square root of 60. Type in 2 square roots of 15. And you get the same thing. It doesn't guarantee that this is the smallest, but at least you can tell whatever you did, you still have what you started with. But I'm telling you, 15, you can't do anything else with. So. All right. Questions on that one? So that's actually more important than the distance formula. You're still going to have some distance formula on the test. But in terms of like doing trig, knowing how to do this is way more important than the distance formula. But this comes up with the distance formula, so that's why I did it. All right, so last formula. The last formula is not for finding out how far apart 2 points are, but figuring out like a halfway point between 2 points. And if you think of like finding a middle between 2 numbers, that's exactly what this formula does. So like, say I had to give you a grade and you had a 70 and a 90 on 2 tests. How would I figure out the grade that I need to give you if those were the only 2 grades you had?
Add them and divide by 2.
Yeah, you add them up and you divide by 2. And that's there's a name for that.
Average.
That's the average. Yep. And that's exactly what you do with the midpoint formula. You take the x's, you add them up, and you divide by 2. That gives you the average of the x's. Then, if you take the y's and you add them up and you divide by 2, that gives you the average of the y's. And that's what the midpoint formula is. It's the average of the x's, comma, the average of the y's. And that gives you what's exactly in the middle. Any question on that one? So on your reference sheet, I would put these two because a lot of people mix these up with the distance. Like here you have x1 plus x2, but in the distance formula, you have x2 minus x1. So they'll mix this up and they'll make that a plus or something. Okay, there's no square root here. So you don't have to worry about generally reducing any square roots. The only thing we have to make sure of is if you get a fraction that has an even number in the top, or you have an even number in the bottom, you reduce it. So if you end up with 10 divided by 2, put 5. All right, let's look at an example of that. And then that'll be a good stopping point. This is the only section we do in chapter 1 in the book. Okay, there's 5 more sections. Most of it is algebra review that we don't really need for this class.
So this is what's going to be on the test this week?
This will be the first section on the test. Yeah. We still have some stuff we're going to do Tuesday, Wednesday, and Thursday.
You sure?
Thursday's a review day. So we have some new stuff Tuesday and Wednesday. All right, so let's find the midpoint. Okay, let's start by labeling them. What could I label the 3 as? Okay, that could be x1. How about, it could have been x2. You could do it either way. How about now that that's x1, what's the 4?
Y.
Has to be y1. 7.
X2,
And
Y2.
13. Y2. All right, let's fill them all in. So we've got x1 plus x2, so 3 plus 7. So we're going to add them up, and then how do you find the average?
Divided by 2.
Add them up and divide by 2. All right, and what's going to be my second fraction?
4 plus 13 over 2.
So add them up, divide by 2, and let's see what we get. 3 plus 7 gives me
10 over 2, but it can be 5.
10 divided by 2 gives me 5. 4 plus 13.
17.
All right, that's an odd number, so you can either leave it as 17 over 2, or if they wanted a decimal, what's 17 over 2?
7.5. Oh,
8.5. Yeah, 8.5. Okay. Other big difference between this formula and the distance formula, this answer is a location. Okay? It's a coordinate. It's 2 numbers with a comma between them. In the distance formula, it's not 2 numbers. It's just square root of, you have 1 number. So that's a coordinate. That is not. Any question on the midpoint formula? All right, so we got done pretty early. Not every lesson will finish that early, and they build as we go. But that's the first lesson in trig. Yeah.
So do I have to write the 17 over 2, or can I write like 8.5?
Either way. Yeah. Okay, either way. Yes.
Do you want us to simplify the fractions, like in like say it's like 7 2/4 or whatever?
Well, I don't want you to leave it as like 10 over 2.
Okay.
I want you to write 10 divided by 2 is 5. Yeah.
Okay. But if it's like that, you want improper? Or?
Oh yeah, we don't ever want to have a mixed number. Yeah, as far as mixed numbers, we never use mixed numbers in trig, like 4 3/5 or something. Yeah. Generally in algebra and trig, we stay away from mixed numbers. Okay. Any other questions on that? All right. Okay, so the homework has two parts to it. The first part is in the book, 15 to 21 odd, that's distance, 39 to 43 odd, that's midpoint, and simplify these 4 square roots. Okay, and by simplify, I don't mean round them off. I don't want like 4.6. I want like what we did in class. Okay, so if you forget the roots, you'd only get half credit because that's almost half the homework. Okay, the roots. Okay, and you've got about 15 minutes, just over 15 minutes. So you have time, you could work on that. If you work on that and get it done, you can show me, check it off, and then there's no.